Question 1. Find the area of this circle. This will involve a formula, so we'll look to put the formula on the first line. On the second line, substitute any numbers in from the question, and we have a radius of 8 meters here. We'll calculate our answer, and lastly we'll check our units to see if they're appropriate. So finding the area of a full circle, we have area equals pi r squared, or pi times the radius squared. Now the radius goes from the center to the outside edge there, so we have a radius of 8 meters for this question. So we'll just put an 8 where the radius goes in the formula, in the next line down there. So we get area equals pi times 8 squared, which we can type into our calculator there. And we get a final area of 201.06 meters squared. Now I've quoted it to 2 decimal places. The question didn't tell us to round it in a particular way, so you get to decide that. But however you round it off, it's polite to tell the marker what you've done, so I put in brackets there to 2 decimal places. And also, as far as the units are concerned, when we're working with area we need square units. The original units were meters, and so our answer is expressed as meters squared. Question 2. Find the area of this half circle. It has a diameter of 14 millimeters. We have a formula to use. We'll substitute all the numbers in the next line down. We'll calculate our answer and we'll check our units lastly. So finding the area of a half circle, we'll take half of the usual area formula for a full circle. So we'll have half of pi r squared, or half of pi times the radius squared. Now we have a diameter in this question. It goes from one edge of the circle all the way across through the center to the other edge. So we'll have to halve that as well to get a radius here. So what we'll do is we'll halve 14 to get 7. That'll be a radius. And we've also got a half to indicate that we've got a half circle involved in this question. So so we get on the second line there, a equals a half times pi times 7 squared, which is a job for our calculator. We get a final answer of 76.97. That's rounded off to 2 decimal places. The question didn't ask for a particular rounding off, so we just indicate down there what we've done for the marker. Now, as far as the units are concerned, the original dimensions, the length of the diameter there was quoted in millimeters. Because it's an area, our answer needs to be in square millimeters in this case. Question 3. Find the surface area of this rectangular prism. There'll be a formula. We'll look to substitute all the numbers in from the question, calculate our answer, and check our units. Now the formula for the surface area of a rectangular prism, we need to work out the area of each face. There are repeated faces. There's a floor and a ceiling and that sort of thing. We've got a length and a breadth and a height. In this case we've got 10 for the length, 6 for the breadth, and 4 for the height. So the system is, we need every combination of those numbers at some stage in the question, and each of them will be multiplied by 2 to indicate that for each face there's an opposite face of the same size. They've got a front face and a back face, a right wall and a left wall, a roof and a floor, all of the same size. So we'll get that system happening here. We've got a length times a breadth times 2 for the floor and the roof. We've got a length times a height times 2 for the front and back walls. We've got a breadth and a height times 2 for the left and right walls. So as long as we get every combination of numbers in that red section there, we'll be sweet. So see in that red area there, we've got a length times a breadth, a length times a height, and a breadth times the height. So every combination. That'll give us our total surface area. So using that system, we can go straight ahead and make sure there's one of each, well, two of each of those numbers in that red section, a 10 times 6, a 10 times 4, and a 6 times 4. And if we multiply each of them by 2, we'll get our final answer there. In this case, 248 meters squared. It's an area question, so we need square units. We started off with meters, so our answer has meters squared in it. So that's the system for rectangular prisms. We can do every combination of the numbers, but multiply them by 2 to indicate that there's a face on the other side for each of them, and add up the total surface area there. Question 4. Find the surface area of this cube. So this will involve a formula, substituting numbers, calculating our answer, and checking our units. So we've got a side length of 5 millimeters here. The surface area of a cube has the side by side for one of the faces, and we've got 6 faces involved as well. So for each face on that cube, we have the side length times the side length, or the side length squared really. And we have to indicate that the cube has 6 equal faces, a bit like a dice. And so the surface area of a cube ends up being 6 times the side length squared. In this case, our side length is 5, so we'll put a 5 where the S is in our formula. And we'll get a final answer of 150 millimeters squared. Original dimension, the side length there was 5 millimeters. So our units we need for area are millimeters squared. Question 5. Find the surface area of this cylinder. This will involve a formula. Next line down we'll substitute all the numbers in. We'll then calculate our answer and check our units. The surface area of a cylinder, we have a formula that's got 2 parts in it. We have 2 pi r squared, which is finding the area of the 2 end circles, or the top and bottom circles there. And the curved surface around the middle there is found by 2 pi r times h. And we have a radius of 7 meters and a perpendicular height of 12 meters, so we'll put them in all the right places there. In for the R is the 7 for the radius in that first section, and in the second section we'll need the 7 plugged in where the radius is and a 12 plugged in for the height. So carefully we fill in the spaces in the formula with the numbers from the question. We'll type that all into our calculator and get a surface area, in this case, of 835.66 meters squared. The question didn't indicate how we should round it off, so we can just decide that. So your answer might vary, and we should tell the marker how we've rounded it off, just to be clear. In the original question we had meters for the radius and the height, so we need square meters because it's a surface area that we're finding. Question 6. 1 centimetre cubed equals how many millimetres cubed? With units of length, the normal conversion rate between centimetres and millimetres is 10, but we've got units of volume here. We've got cubed units here, and so we have to cube the normal conversion rate. So the normal conversion rate was 10. We need 10 times 10 times 10 to get the conversion rate between centimeters cubed and millimeters cubed. So we have a conversion rate of 1,000, so that means we're multiplying by 1,000 or dividing by 1,000. How we decide which is indicated by whether we're breaking a set of units up into smaller units. Therefore there'd be many more of them, expecting a larger number, and that's the case we're using here. So we'll multiply by 1,000 here. When cubic units are used, we must be careful to cube the normal conversion rate. We've got a conversion rate here of 1,000, so 1 centimetre cubed contains 1,000 millimetres cubed. Question 7. Find the volume of this triangular prism. This will have a formula. We'll substitute all the numbers in on the next line. We'll calculate our answer and check our units. For the volume of a prism, if we're given the area like we are here in that blue area, we've already got an answer for that section. All we need to do, when we're given the area of the cross section, we call it, we just multiply by the height. In this case, the height isn't from the floor, it's how far back the prism goes. It's kind of like the distance between the front triangle and the back triangle. So that's what we call the height in a prism. So we just take the area and multiply it by the height. So volume equals area times height there. We've got an area in the diagram of 13 centimeters squared, and we've got a height or a distance to the other end of 9 centimeters. So we'll have area times height here. We'll have an area of 13 and a height of 9. And when we multiply that out, we have a volume in the end of 117 centimeters cubed. Now there was centimeters and centimeters squared in our question, but because we're finding a volume, we need cubic units. So that's why we've got centimeters cubed in our answer. Question 8. Find the volume of this cylinder. This question will involve a formula. We'll substitute all the numbers in on the next line, calculate our answer, and check our units. Volume of a cylinder, we get to just have the area of the circle, which is given in the question, 7 centimeters squared, and just multiply it by the height that we're given in the question, in this case 14 centimeters. So it's just the area of the end times by the height. In this case it's 7 for the area given in the question and a height of 14. So we'll just multiply them together. 7 times 14, 98 centimeters cubed. We had centimeters and centimeters squared in our question, but we need cubic units for volume. Question 9. 1 litre equals how many millilitres? Units of capacity has a fact that says 1 litre equals 1,000 millilitres. So that's just a fact we might like to remember. So the conversion rate here is 1,000, and we'll be multiplying by 1,000 because we're breaking the litres up into smaller units. So we're expecting a larger number, hence the multiplication there to make things larger. So we'll just get an answer there of 1,000 millilitres. That's just a fact that we should remember. Question 10. 1 gram equals how many milligrams? For the units of mass, 1 gram equals 1,000 milligrams. We're breaking up a gram into 1,000 parts. The prefix milli is indicating 1,000ths. So the conversion rate there is 1,000. Because we're breaking the units, the larger unit up into smaller units, there'll be more of them. We're expecting a larger number of them when we break things up into smaller pieces. And so we'll multiply by 1,000. 1 times 1,000 is just 1,000 milligrams in this case.